everybody, welcome back to the Sheet Metal Professor channel. Today we're going to lay out the funnel picture. This was a subscriber request. They were having a little trouble with the math. They asked me if I could take a look at it, so we went ahead and we made it. I didn't do all the fabrication in this episode. I did a lot of math in some fabrication. I did the edge wiring and a few other things. If I did too much, it would have been like a 2-hour video and it would have been crazy, or I would have had to break it up into 2 episodes. So we're going to go through all the math and some of the layout. I hope you enjoyed the episode. I also went and visited Mike Taragna's shop in New Hampshire this weekend. Mike has his own unique line of interior and exterior lighting. I'll leave his information in the description. He has an Etsy store and he's on Facebook and he's got quite a following. Mike and I will probably do an episode together. Lighting is something that's always interested me, so I think it will be something fun we could do here on the channel. So with that, we'll get into the video. Please enjoy, and I'll see you at the end. All right, so this was a request by somebody. They were trying to do it, and they couldn't get the math to work out. So this is a funnel picture, and I have to say I have to give Bob Ross must be a genius, because anybody that can film something and not get it wrong and do it in one take is a genius in my book. I think he was underrated.
Yeah, we're just going to use this little tiny 2-inch brush and put in a happy little background back here.
So I've laid out the cylinder. We're going 5 to 4. You don't have to do that. You can do it straight. I think it looks a little nicer with a taper to it. So we're going to start out with a 2-inch radius, and we're going to develop a quadrant here. If you've watched my squared around videos, you already know how I do this. So we start with our radius, and then we'll break this up into different segments. It's very important that if you're going to do this thing, that you keep a very sharp pencil. So now we want to roll those up into the cylinder top. But now we want to find 45 degrees here, because we're going to do our neck on a 45. And I'm going to make the neck 1.25 inches. We'll simply draw 1.25 inch radius here, and then we'll bisect it so that we get 45 degrees. It's very important to make sure when you're doing this, nothing moves, because if you lose something on this, it throws the whole thing off. Definitely double check what you're doing. Measure twice, cut once. And I wanted that 1.5 inches, not 1.25 inches. I want the opening to be 1.25 inches. Develop a quadrant for that. 1/2 1.25 is 5/8. So let's bisect that. And then we should have 5/8. I hate this little divider. You can pull 90 degrees out of that. We can bisect it. Yeah, I'm doing them in pen. Concerned about these numbers. So we'll call this 1, 2, 3, 4, 5, 6, 7. We'll call this 7 to 8. We'll call this a seam. Then we'll call this point 8, 9, 10, 11, 12, and we're not concerned about anything else. Okay, so I'm going to carry this line across. We're going to pick up a 2-inch radius, and we're going to draw out our 4-inch circle. We're going to divide up some quadrants on this for the bottom. So I know that I'm picking up these 2 points. I'm picking up 12 and 16. So whatever circle I make, because right now they're almost putting this thing at the top, probably about a 1/2 inch back from what I see. But I don't like that. I want to make that a little bigger. You can make this as big as you want. You just have to make sure the points cross. So this point here should always be the same as 12, basically. So because we're on an angle, it's going to grow a little bit. So it's going to grow by about a 1/4 inch. So to look at that, if we wanted to triangulate that, let's say we had 1 inch. Let's say we had 4. It grows a little bit. But we'll use 4 1/4 just because it's an even number. My 4 1/4 circle is 2 1/8 as the radius. And I want to cross these 2 points. So in order to do that, I got to come up a little bit. I want to grab it there. Grab it there. I want to grab it there. The points don't change that much at the bottom. So now that I know that, and I know that I grew a little bit, I don't even think it's necessary for you to do this. But I don't like the top of this being flat. So now I can grab this line, which again represents 12 to 16. I can grab the apex. I can come from 12, and I can put a line here. From there, I can grab 12. I can grab that apex and can draw a line. And I'm going to draw this long just because I need something to square off of. So I already know what my divisions are for that, but I also need my divisions for the 4 1/4. So let's go back to 2 1/8 and we'll draw out our quadrant. Just so we can get spacing. But now I know I got the right radius. I know I'm here, so let me find my midpoint. And there's my midpoint. Now I can take my midpoint. I can develop that. I can pull 90 degrees off of this. I already know what my spacing is because I still have this set to 4 1/4. Now, if I'm correct, 12 here should hit this line. And it does. So now, you can just work 90 degrees off of this line. And again, it should be 90, which it is. That's why we drew this long line out here, just so we can see where it grabs it. So we're right there. Then we simply just get 90 off of every other one. But we're only concerned with this spacing here. And that was a little wonky. We can call this 12 also, 13, 14, 15, and 16. And this is why I wanted to add a little bit now, because if you look, at least it gave us a little bit of an angle to the top. So at least it's not flat and it doesn't look stupid. You have to keep everything sharp. This thing will like really break your balls. So we don't need anything here. I definitely don't need this, but we have our data points now. We don't need any of this stuff in the middle. Now all we're concerned with is these points. Now we're going to be looking for 1 to 15, 2 to 15, 2 to 14, 14 to 3, 3 to 13, 4 to 13, 4 to 12, and this is where our corner starts to develop. And then 4 is going to hit everything to 10. Because what we're trying to do is develop this corner. This is the most important thing. Then we'll go 10 to 5. We'll go 5 to 9. We'll go 9 to 5. What a way to make a living. And then we went 9 to 5. We went 9 to 5. Then we'll go 5 to 8. And then 8 to 6. And then back. There's a lot of close points in there that you really can't see. The first thing I'm going to do is develop a baseline. Work off of. And we're also going to develop a triangulation line. On this triangulation line, we're going to make 2 scales. Because I have so many condensed points, I don't want to crunch them all together. So the first point we're going to have is going to be 2. Then we're going to have 3. And then we're going to have 4. 4 I know is 5/8. Now, 2 and 6 are the same. 4 is its own. 3, 5 is the same. And 2, 6 is the same. So 4, 3, 5, 2, 6. They're the same distance here. So now that we have all the data, we're going to take points 1 through 16. And we're going to start with a 90-degree line. We're looking down on the top of the fitting and we're working the back. So we have point 1 through 16. Now we don't have to triangulate 1 through 16. We're already looking at it triangulated because we're looking at it from the side. So we have true length on that number. So we're going to call this 1, and we're going to call this 16. First thing we're going to do is we're going to grab spacing. And that spacing is good. So whatever spacing you use throughout the draft, keep that one wherever you measured it from. Don't keep changing it. So whatever point we develop here is going to be point 1 to 15. So we're going to take 1 to 15. We're going to bring it over here. We're going to mark our true length line. Then what I need to know is 15 from the base. Now I need to know what 15 is. I'm also going to mark this over here. For what reason, I don't know. So we're going to take 1. This is going to be 1 to 15. 1 is our baseline. 8 is also a baseline measurement. So we're doing 1 to 15. Now we just take that same measurement from here. Now we have true length of how much that line is changing. So we'll take 1. We went from 1 to 15. 15. Now this is a very small thing. I was going to blow this up just to record it, but I was afraid that if I did something different or different sizing, if somebody else tried this, it wouldn't be the same. So the next thing I want is my spacing here. And this is very important that you have something that does not move. Because if this moves on you, it will throw this whole freaking thing off. And I'm not using a marker because that little crappy compass I have moves every time I try and use it. This will stay. I will not adjust this anymore. So that's going to be 0.2. So now we're going to go 15 to 2. So 15 to 2. And we'll bring it over here. You can alternate. What I like to do is when I'm coming back up, put it in another scale. So we're going to call this 15 to 2. We're still using the spacing on 15. (15 to 2). This is also called the short method of triangulation. I don't know what the long method is. This could be the long method for all I know, because it's taken me forever to do this. So 2, 15 to 2. I'll draw that in. Now we're going to go 2 to 14. Again, use the same spacing you were using. So 2 to 14. Get our 14 spacing for our half circle. 14 is going to go up here. And we're going to 14. Normally I wouldn't draw this out, I'd just grab my point and go, but just to teach this, we're going to do it that way. So now we're going 2 to 14. And it's nice to have a line down here because you can see the symmetry in your fitting. A lot of times I'll draw another line as I'm going up. Otherwise, if you're really not paying attention or something's off, it'll start to go wonky on you. So let's take 2 to 14. So now we want to develop 0.3. We're going to go 14 to 3. And we're only doing these 2 scales, so we're not crowding all our numbers. A lot of these marks are almost the same, especially when you get down in here, and you really don't want to confuse the 2 of them. So 14 to 3. This has got to be like watching Ben Stein and Ferris Bueller's Day Off.
Bueller.
Get 13 developed. And we're going to go from 3 to 13. Get our length for 13 on our semicircle or quadrant. The cool thing about knowing this is you can do some really complex shapes. So we are going to 3 this time. I really wanted to show this to you because now you can see that sort of like the fitting is curving over. If you make a mistake, you can go back pretty easy. To 13, we're still riding that line pretty tight. Not much change there. So now we want to develop 4. And 4 is going to have a lot of points to it because we're going to develop this corner here. So 13 to 4 this time. We're going to rotate over to here. Again, we're pulling 13. To 4. So what you're seeing is this bowing out, and what you're seeing is that circle is starting to dip down. That's what you're seeing there. So 13 to 4. Then we'll get our spacing to 12. And then after this, we have to switch down here. This spacing down here is different. So again, we're going to continue to use the same spacing we've been using. So 13 to 12. 13 to 12. 4 to 12. Again, these pretty much are the same. But I'm going to use that one there. So this is 12. We're going over here. See how we're coming out? Like 13 was the apex. So we're starting to come out like that. Now if I'd have the other one in here, you'd see that it was over here, and you'd actually see that circle. So 4 to 12. And then now this thing is going to make a crazy turn. So now we want spacing from 11 to 12. Over here. I'm just going to grab it, just make sure they're all the same, and like I said before, make sure you're using the same spacing. So 12 to 11. This is really about to go. All right, so now we want 4 to 11. And again, we are using the spacing down here now because we're now connected to the base. So this one fits better over here. And it's sort of landed on another one. So let's get spacing on 11. And that is 4 to 11. Tight line. Four to 11. 4 to 11. So what we've done is we've just made this corner. We've just turned the corner right there. And so far we're pretty symmetrical. As you see, we've now turned. That's that turn right there. So again, we need spacing because 4 touches a lot of different points. So now we want to pick up 10. So we need 4 to 10. It's right there. We'll take spacing off of 10. And I'm not going to bother with that because you can barely see what's going on there because they're tight. So again, 4 to 10. 4 to 10. Ten. That's a pretty hard move in there. Now we're going to go 10 to 5. And I'm just scratching the paper with this one because those little dividers I have just completely suck. So 10 to 5, 10 to 5, 10 to 5. And let's see if we can pull it over here. Yeah, we'll pull it over here. Get spacing 10. Sometimes you can do the bottom on one side. This is probably definitely one of the craziest things I've ever tried to do. So 10 to 5. Get spacing again to 9. We're going to go 5 to 9. There's 5. We're going to grab 9. We grab it here. We want our half circle for 9. Over 9. Just want to check symmetry here. Pretty close. I'm doing really good. So we're at 9. That was 5 to 9. Now we want to get 9 to 6. So 9 to 6. You could do a lot with this method of triangulation. So now we want to get 6 to 8. So again, let's pick up our spacing. Find our line for 8, because we're already up here at 6. This is our 6. 1, 2, 3, 4, 5, 6. We are at 6. So now we want to get 6, 8. And we're getting closer to where this is starting to close up on us. So 6 to 8 actually runs off our baseline because 8 doesn't have a height. So we're going to grab 2. And this is barely going to change. 2, 6. Again, 2 and 6 are the same, so we're at 6 and 8. I'm going to grab that. Actually looks right. Now 8 is our last spot. Now we're only going to have to bring one to 7. So if we mark out 7, and 7 and 8 is just a baseline, it's 0, 0. And 7, 8 is also the seam. Now we can take a French curve kind of lucky on that one. Yeah, just keep that straight. So then, you know, you want to add, depending on what you're going to do with this, how you're going to connect this, you're going to want to add in some kind of material for a seam. That 5 point looks a little wonky. So again, I would add material in here. I would never count on this thing being perfect. But, you know, I know it's a hole, but if you add some material there, if something's wrong, you have the ability to... If you add some material in there, you have the ability to put that down on a bench or on a shear and take a marker and go around it and actually straighten out a line. Let's add a 1/4 inch seam here. Now, I don't know everybody, this is kind of an advanced project, but I'll probably do a groove seam here. When you're doing groove seams, if you're doing a 3/8 groove seam, you want to add 3/8 to each side, but you only want to bend a 1/4 on each side. And the reason for that was when we put the tool on this and we knock this down right here, that eats up 1/8 inch of that measurement. So we've already bent a 1/4, so that gives us the total 3/8. And so forth and so on. If you wanted to do a 1/4, we would only bend about 3/16 because we're going to lose a little bit in that bevel from the tool. So on this one, I'll probably use a 1/4, and I'll probably only bend like 1/8 to 3/16. Really don't need that big of a seam here. So let's cut this out. We'll tape it together and see if we're any good. So that is correct. So what I was saying before, when you get something, and once you get it formed out, and if it's not perfect or you got something weird going on, like let's say you didn't like where that hole was, you can take something and elevate it, put it on your shear or something flat, your bench plate, and just go around it with a marker if you leave enough material, and you can actually get that flat the way you want it. So that, I mean, that's just a little trick of the trade, but that's a way of getting something the way you want it after you've done it. And you could do the same thing here. Once you get it formed the way you want it, you can put it on like here, see that? So we can take that now, and we can see where it's not straight. Of course, we don't know where this is going to land because it's not metal, but that's one way of getting something flat after you create a pattern, to get it where you want it, and then take this and transfer it to a metal pattern and hang it on the wall. So that's how we lay that out. I've done a couple different takes tonight to get this correct. Actually, when we started out, I had to redo that circle, but it did work out. I saw it coming where it was going the wrong way, and I had to make a little bit of an adjustment, but we got it right. All right, so we're gonna go ahead and we're gonna lay out the container and we're gonna lay out the spout. I'm just gonna do this the simple way. I laid out my body. I drew 2 lines up to an apex. If we were gonna do radial line, we would just go out to the left or to the right and then just take our segments and measure it out. But you can also do it this way. My earlier clone video, I did it where we did it in radial and we did it out to the side, but sometimes when you do it that way, you don't have enough material if you're working on the metal. So we'll do it this way this time. And there is another way to do it where you can figure out the cord lengths. They make an app to do it. Probably too much for me to figure out. So we'll just do it this way today. I did draw a quadrant right here just to get some spacing, because we're just going to work from the center today. So we're just going to simply draw out an arc here.
Oh no! We suck again!
Yes, I rigged up a divider. So I did some math just to show it. 4.5 is 7 7/8. Well, we could just come over, go 7 7/8, and we could put a mark here. Now if I come back through, go back to my apex and take this point, theoretically, the top should be correct here with the proper measurement. So I should have 12 5/8. And we have exactly 12 and 5/8. So that's one way that you can do it. You can do it with quadrants. It doesn't always work out for me sometimes. But if I take the quadrant and I go 1, 2, 3, 4, 5, and break the pencil, and 6. You can see we're pretty close. So, you know, if this thing is just a hair off, it's going to show up in the drawing. 3, 4, 5, and 6. So, 1/8 of an inch, but not much. So we can get that one from there, so we can make our pattern for our body from that. And now we could come over and we can actually do this one if we want. We got too much divider here. You know, this one I would almost rather just do it to the side. We'll do them each different. But just like in radial line development that I've showed on a couple episodes, we can just come over, we could take a line from our apex, we can break some more pencils, but trying to do over here what we did here, it's so small it's kind of a pain. So here we have 3.534, which is a 32nd of an inch over 3.5. It's really not worth even looking at it. So we'll just go 3.5 there, which is almost impossible to do. You have it there. And the same thing if we just go up to our apex. Theoretically, I should have the 2 3/8 here. I mean, it's not going to change much, but I have it. Now, I talked about groove seams before. So we're going to add 3/8 to each side of this one. Actually, I'm going to do a 1/4 instead. This is a small piece. Same thing here. We'll add a 1/4. Then I'm just going to add a 3/16 to the top of this. I'm going to fold that inside. And here I started bigger, so I already ended up with what I needed. So there's our patterns for our body and our spout. We could cut those out. Now that we have all our patterns, we could transfer everything to metal. I still have to make the base. The base plate here, we're going to do a double seam, but I want to wait until I get this formed out and I put my edge on here for my double seam, because I want to see what that exact diameter is before I make that piece. Sometimes they come out an 1/8 inch off, give or take, and you don't want to make a piece that's too big or too small. So you're always better off to get everything formed up before you make a finished plate like that. I had some of this light 12-ounce copper, a couple sheets of it that I picked up on a machinery pick. So I'm going to use this because this piece is very small, and I think the 16-ounce will be really unforgiving. I'm going to work on the tarnish side because I'll be able to see my marks easier. And once we get these patterns on here and they all work out, we'll transfer them to metal, and then we'll hang them on the wall for when we're old and retired and nobody wants them. I went to a place the other day and the guy did Jaguar stuff for all the old Jaguars, the old XK Jaguars from the 50s. And he was 80 years old, and I bought a couple sheet metal machines off him, and he had all these patterns on the wall for dashboards, quarter panels, fenders, you name it, he had it, gas tanks. And he was retiring and he was throwing them all away. Nobody wanted his patterns. So when you make your patterns, try not to put too many notches in them. If you put notches and stuff, you're gonna throw the whole thing off. Just write on your patterns what your notches are supposed to be. And anything that's straight, go ahead and put a straight edge on them. Because those cardboard edges are never perfect. And if you have a really wobbly line on a seam, you're gonna feel it when you go to put it together. Scrap gods. Anybody ever seen these before? I bought 4 pairs of them from Elizabeth Turk in New York. I bought a bunch of machinery off of her, and I've Googled them. I can't find them on Google. Nobody knows anything about them. The only thing I could find on the number is it's some kind of German. It's some kind of German patent. But they cut in any direction, and they'll cut like 1/2-inch radiuses. They're amazing. And again, I've left some material in here, so when we form this, if that spout is too big, at least I could take a little material away. You're always better off having material to work with than not. So we're gonna bend a quarter here. Really wasn't sure what I wanted to do at the top of this. I wanted to put a wired edge on it, but I think I'm just going to roll it in and we're going to solder to it. Alright, so instead of putting this in the roller, we're actually going to do this with the layout lines. We're going to put this in the brake, and we're going to bend it on the layout lines like we would have squared around. I think it'll give it a neat look. And I'm taking it to the edge, not to the edge, but just inside, because we're going to put a wired edge on this. We're physically going to insert a piece of wire around the edge to roll the metal over it. So now we'll put the seam on it. have to undo it a little bit. All right, so there we have it, all bent up. And now we're ready to put the bottom seam on, and we're ready to wire the back. All right, so I laid out the body. I did the same thing. I used my layout lines. Not exactly my layout lines, but I did take the dividers and put the same marks on the cylinder with the brake. Just think it gives it a little something extra instead of putting beads in it. We're gonna do a groove seam on this. I am gonna use the machine to do it, but just to show you the actual hand operation, I'm gonna do it with a physical hand seamer. So groove seaming, and I explained it in the layout, these come in different sizes. This one is a 2. The larger the number, the smaller the opening. So if you had like a 00, that's like a 1/2 inch. This is a 2. The next one up would be a 3, which would probably be about a 1/4 inch. This actually might be a little big. We're gonna find out. Don't use your good hammers when you do this. You really don't want to be banging steel on a good hammer. But yeah, that's the right size. So you want to start your ends, and you want to keep moving. Again, this material is very light, so I don't want to beat the hell out of it. But that's the angle I was telling you about that you got to allow for when you put it on. We'll give that a little more. And then if you want, you could center punch that when you're done to hold it together. And then if you're doing a wire or something, try and leave on one of your notches a little bit of overlap so that overlaps your wire. If you don't leave an overlap here, that will transfer over into your wiring and you'll have a sort of a crappy edge there. So there's our cylinder. And now we'll groove seam the body on the top. Now for this, I'm gonna have to use a different stake. This is still kind of narrow, but it'll serve its purpose. And then we'll actually put some solder in this before we start messing around with it. And all this will polish off afterwards. And then another little trick that I was talking about during layout. So if you look at this, we're a little uneven here in the layout. And if you leave yourself a little extra material, you can put your piece down and on a flat surface, and you can come through with a pencil or a marker if it doesn't break on you. You could come through with a pencil or a marker. And you can do any side of this. Just make sure your diameter is right the way you want it. And then you can actually come through and get rid of your high spots. And then when you run this through the machine, you're going to have a flat surface, so it's not going to be in the machine changing direction on you, and it'll look a lot better in the outcome. So now we're going to move over and we're going to put a wire on this. And then after we do the wire, we're going to put an edge on here. We're going to use the beater. And I think we're going to bead the body too. And we're going to solder to that bead. I think that should work out pretty well. So now we're going to go over to the turning machine. And we're going to turn this edge for a wire. And then we're going to do this bottom edge with the beater. And we're going to do the same thing here. We're going to put a wire in here. And the main idea is to solder right onto that wired edge. So I'll have a beaded edge here, a wired edge here, and then we'll just solder it on the inside to those two. Okay, so we're going to set this for a wired edge. Now this is something you have to play around with yourself and find the right measurement for what you're doing. I'm going very easy on this stuff because it'll split on me. And what this bead is doing is it's actually the same size as my wire. Okay, so now I've got my wire, and I'm simply just going to make a couple bends in here to grab it. Pull the material over. And then we're going to run this through the wiring machine. Alright, so this is a wiring machine. This is an older Pexto machine. So again, I'm going very easy on this because this material is going to split on me if I'm not careful. we'll make a couple passes over this, and this will give us a nice and you want to make sure you got the right wire in the right wiring machine, because if you don't, this wheel will cut through your material if it's riding down too hard. So what that's doing is that's tucking that metal back up underneath that wire. So that wire will give us a lot of reinforcement around that edge. And it'll also help us with our diameter here, because we'll be able to hold that form. So what we'll do now is we'll bead the bottom of that head, and then we're going to solder right to this joint. This needs to be cleaned up a little. But that's easy enough to do. I hope you enjoyed the video. I'm working on another one now for a brass eccentric funnel for a friend of mine who does motorcycle work. He's tired of doing the funnel where it goes into the side of the motorcycle, or he has to put a rubber hose on it. So we're going to make the funnel flat on one side so that he can do his work. It'll be an interesting episode. We'll cover some concepts on wiring, beading, and a few other things more in detail. Please like and subscribe, and we'll see you in the next one.